Welcome back. We're going to finish up our unit on statistics with scatter plots and correlation. Before we get started, how are you feeling today? Use the Nicolas Cage chart to help you. Awesome. Let's get started. Here we have 3 graphs. We're going to describe these 3 graphs using these 3 words in the word bank. We're going to focus on the slopes, or the direction of the line. You can describe the slope as being neither negative or positive. Let's take a look at our first graph here. Would you say that this is neither negative or positive? So this first one is going downhill. So this would be negative. Let's look at our second graph. Neither or positive. This one is neither. I can't tell if that line is going uphill or downhill. So that means our last one has to be positive. It's going up. This type of graph is called a scatter plot. It shows the relationship between 2 variables with dots. You have your independent variable, which you'll recognize from science class. It's on the x-axis, and your dependent variable is on the y-axis. And sometimes with these scatter plots, you could have a dot that's out of the way. We call it an outlier, and we tend not to focus too much on those. But we look at the rest of the dots that are more closely related, and we're going to call that the correlation. That just describes how these 2 variables are related to each other. Kind of like we did in the warm-up. Is it positive, negative, neither? And there are some more factors we will consider. Here we have 8 different scatter plots. They're all kind of unique. We're going to use these word banks on top to describe these graphs. And when possible, we're going to try to use one word from each box, unless it's none, and then that'll be the only word that we use. So let's start with D. So if I'm looking at graph D, I have dots that are in a very straight looking line. So if I had to describe graph D as positive, negative, or none, what would you describe graph D as? So this one is going uphill, it's positive. Okay. There are 2 other graphs that are positive. Which ones would those be? So that would be G, that one's positive, and E, this one's positive. There are 3 graphs that are negative. What would those be from the ones that are left over? Negative are the downhill ones. So that would be F, A, and C. Now the graphs that don't have a negative or positive correlation, we'll just say there's no correlation. Those are none. Now there's another way that we can describe our graphs. We can have a perfect correlation, a strong correlation, or a weak correlation. So if we take a look again at our starting graph, the positive one, every single dot is in place to be a perfect straight line. So because of that, I'm going to say that not only is it a positive correlation, it's perfect. These dots are in a straight line. There's one more graph here that is perfect. Which one do you think it is? Well, that's going to be F. F is in a perfect straight line, so it's negative, but it's also perfect. Okay, let's take a look at our leftover graphs. We have graph A and graph C. Which ones do you think is stronger? Stronger meaning that the dots are closer together. So the stronger one would be A. And the weaker one is C. And then very similarly with E and G, E is weaker because the dots are kind of further apart, and G, they're stronger. This will make more sense the more we practice, but this is how you can describe scatter plots. So correlation, known as the letter R as a variable, has a scale here. So your perfect positive correlation would be labeled as 1. If I was to turn that into a percent, it would be 100%. What do you think a perfect negative correlation would be? -1. And if there's no correlation, that would be a 0. So it's on a scale from +1 to -1, or -1 to +1, depending on how you look at it. So let's look at this scale here. Starting at a perfect positive correlation, we have our +1 all the way to our perfect negative. So I imagine it as you're pinching these dots together right here. And if you're really strong, you can pinch them very close together. And then when you start to open up your finger a little bit, the dots start to spread a little bit. So it's not perfect, but it's really high up there. It's still very strong, and your ranking drops a little bit from 1 to 0.9. You can think of it as 100% to a 90%. Then it drops a little bit more. They're starting to spread apart, and then all of a sudden there's absolutely no rhyme or reason, and there's no correlation. It's at 0. And then your dots can start to form in the opposite direction. They're coming together, but they're going downhill. And then the closer they get together, the stronger your correlation is. So you can have a strong positive or a strong negative. It doesn't matter if it's positive or negative, it could still be considered strong. It just depends on how high the number is and how close together the dots are. So let's say we wanted to rank these correlations from strongest to weakest. Remember, you can have a strong negative and a strong positive. The sign in front doesn't really matter. So which would be the strongest to the weakest? So our strongest would be the highest number. Don't really care if it's positive or negative, because those can be considered strong either way. And after 89, we have 72. And then after 72, we have 53. And then 27. So without looking at the sign in front, I'm just really focused on that number, kind of like a test score. Like an 89 would be really strong, 27 would be really weak. And let's see if we can rank these scatter plots. Which one do you think? I'll do this in order, and we're going to use each one once. Which graph do you think goes with -1? That would be F. Okay, I'm going to get rid of my -1. Which scatter plot would be a +1? That would be graph D, +1. Okay, I'll do this kind of like a median, just working my way to the middle. Actually, yeah, so which one of these would be a strong negative? I'll give you a hint. It's either going to be A or C. Which one would get the -0.9? That would be A. This one's stronger than this one. These dots are a little further apart, so they'll get those. So that's done and that's done. And let's do our 0.3 and our 0.9 between E and G. Which one do you think would be 0.9? Which one's a little stronger? That would be G. And this would be 0.3. They're both positive because they're going uphill. And then our two leftover ones are the 0 ones. There's absolutely no correlation there, so they don't get a number, they don't get ranked. Oh, I don't know why I crossed these out. That would be, well, again, 0.3 and 0.9. Let's see if you can unscramble the sentence. Okay, you could have done this a couple of ways, but I would say a strong correlation is close to -1 or 1, doesn't matter which one, could both be strong. Let's look at a multiple choice. It should get a little easier now. Looking at these dots, would you say that these dots right here have a positive, negative, or no correlation? They're going uphill. So it would be a positive correlation. So any choice that has a negative number can be eliminated. Now, would you say that this is a strong correlation or a weak correlation? Remember, strong means the dots are close together and weak means they are spread apart. This would be strong. Now I'm looking for the higher number. Think of it as test scores, 90% versus 30%. Which choice would be a strong correlation? That would be choice B. You could think of it as a 90 is better than a 30. Let's do another one. This one talks about the correlation coefficient, or R. We're just ranking this one. Which choice do you think matches this correlation? So here's how you do this. I know that it's negative, so I'm going to get rid of any choice that is positive. And my options are that it's either a perfect line or it's close to perfect. And these dots are not in a perfect line. A perfect line would be like this, super close together. So between a 93, which is close, and 100, which is perfect, I'm going to go with the 93. Right. This is something you would see in a calculator if you were to calculate linear regression. We're not going to do that this year, but let's say they wanted to know which phrase best describes this relationship. This is your correlation coefficient. Would it be strong negative, strong positive, weak negative, or weak positive? And let's just kind of like focus on this part of the number here. What do you think? Well, first of all, it's clearly negative, so I get rid of any choice that says positive. And an 89, that's a high number. That would be a high test score. So I'm going to say that that would be strong. A weak correlation would be something like negative 0.25 or something like that, like a 25. That's not good for if it was a test score. Yeah, let's look at another scatter plot. We got our distance traveled versus the time, and what we can use is the line of best fit. Let's say we wanted to predict, which means an educated guess, how many miles you would travel in 8 hours. So let me just start connecting my dots here to make my line of best fit. All right, so then 8 hours would be about here. I go up. Well, it looks about 65 miles. So yeah, line of best fit is for taking guesses. Here's a scatter plot. It shows the relationship between members in the family and the grocery bill. The most appropriate prediction of the grocery bill for a family that consists of 6 members is, now 6 members is right here. You're missing the dot. So which one of these dollar amounts do you think would fit for 6 members? My dots seem to be like going, oh, I should probably use green, it's positive, like going like this. So if I was going to make a prediction for 6 members, I would guess about 300. 400 seems a little high up there. And 500 is definitely too high up there. And then 100 would be way too low. So there we go. And we're going to talk about what correlation really means. So there's this famous saying, correlation is not causation. Causation, what do you think causation means? What word do you hear there? So causation means cause, like cause and effect. Here's an example I like to use. Let's say it's really sunny out, it's hot out, everything's dry. That might cause you to go grab some ice cream to cool off. If it's also really sunny, you might also get a sunburn, which is, a sad thing, but it happens in the sun. Now, let's say you have your sunburn and you're holding your ice cream. Are you going to look at your ice cream and say, hey, ice cream, you caused me a sunburn? No. So just because the ice cream and the sunburn are happening at the same time, they're just correlated. Correlated means they have some relationship, and the relationship has to do with the sun. So the sun causes the ice cream, and the sun causes the sunburn, but there's just a relationship. Here's an example of correlation versus causation. Here we have some silly graphs. People who drowned in a swimming pool versus the number of films Nick Cage was in. So I don't think Nicolas Cage has anything to do with people in swimming pools. Here we have letters in the spelling bee versus people killed by venomous spiders. So even though these graphs look very similar to each other, the spelling bee has nothing to do with spiders. So these are just correlated. There's some kind of relationship there, but neither one is causing the other thing to happen. Let's do some examples. Let's say we have a graph here. We have cans of soda sold and ice cream bars sold. They tell you that the correlation is 0.96. So let's say you had to decide which statements can be correctly concluded, like without a doubt. Is it 1, eating more ice cream causes a person to become thirsty? 2, drinking more soda causes a person to be hungry? Or simply that there is a strong correlation between ice cream sales and soda sales? Well, I don't know the science behind 1 and 2. That's not directly proven in the graph. The only thing I know is that there is a relationship. It's a strong correlation because 0.96 is strong. So it is going to be choice 2, 3 only. Just to remind you, a strong positive be something like positive 0.89. Your dots are real close together. So let's say your hours of studying versus your grade. If the hours are going up, the grade is going up. That's considered a positive correlation. A negative correlation happens in the following situation. The minutes you're on your phone during class, as that goes up, your grade would go down. So when you have things going in the opposite direction. So the minutes were going up, the grade was going down. So it was a negative correlation. In this case, the hours were going up and the grade was going up. So if you have the same direction, it's going to be positive. If you have a different direction, your correlation will be negative. Now let's look at another example. We have the popcorn sales versus the soda sales. Which conclusion can be drawn from the scatter plot? Is it 1, there's a negative correlation between popcorn sales and soda sales? 2, there is a positive correlation between popcorn sales and soda sales? 3, there is no correlation between popcorn sales and soda sales? Or 4, buying popcorn causes people to buy soda? Here's how you do this. The dots are going uphill. That looks positive to me. So I look at my only choice that says positive correlation, and there you go. I know there's definitely not a negative correlation. I can see that there is clearly a correlation because otherwise the dots would be a total mess. They're not. And this was never, I didn't even do an experiment, so I don't know. And now we're going to decide. Does the following have a positive correlation or a negative correlation? Now remember, positive is when both things are going in the same direction, like both things are going up. Negative would be when they're in different directions, like the minutes on the phone goes up and the grades go down. So example A, as the amount of ice cream sold per month increases, the amount of time spent in a pool increases. Positive or negative correlation? Both going up. So that would be a positive correlation. Look at our last one. As the population of foxes increases in an area, the population of bunnies decreases. Positive or negative correlation? Different directions, negative correlation. It's a sad one, but I guess this happens in the world of bunnies and foxes. Alright, this was fun. Just let me know what you thought of the lesson, and I'll see you next time.